so this question, they give you f of x is x squared, and they want you to make a graph. G of x equals -3, the quantity x minus 4 squared plus 5. All right. So this is using transformations in the transformation rule. So we start with y equals x squared right here. And we have the nice graph here that I made on Desmos. And you can see it's a parabola, its vertex is at 0, and this is kind of the sort of the mother function for all the quadratic equations, quadratic graphs. So when you do your transformations, you want to start, you use the order of operations to do them, right? So we're going to start with our parentheses, inside the parentheses, and it says x minus 4. So that means we're going to shift it to the right 4 times, right? So if you have, let's see, what should I write? Okay, so if you have f of x, then f of x minus, say, h, and you shift it horizontally. If it's positive, you go to the right, right? And so it's minus h. So in our case, h is 4. And if you do that, see, look, you get this graph here, and the red one is the original sort of mother function, x squared, and then we have the new one, f of x minus, was it 4? Yeah, f of x minus 4. So you can see that one in the blue, and it's shifted over to the right 4 spaces. So then the next thing we're going to do is multiply it by 3. Okay, and so this one, you have, if you have f of x, and then you take a times f of x, then you stretch it up, right, with a. So if it's positive, you stretch it up. And so we can see that we did that here. So you can see the green one is the stretched function. So yeah, the green one is going to be, let's see, the green one is f of x equals, what was it? X minus 4 squared, and then we multiplied it by 3. So that's this green one. And you can see it's sort of stretched up, so it's like a lot steeper. Okay, and then the next thing we got to do, it was actually negative 3. So, I guess it can only go so far. All right, we'll have to make a new board. So we have negative 3. So that one looks like this. So this one, you can see the purple one is the negative. So when it's negative, like when a is negative, you reflect it across the x-axis. So the points that are, so we're using the green one was the last one. So the points that, like this point here is going to be this point down here. It just gets reflected. So like this distance and this distance are equal. And you do that for all the points, and then you get your new graph. So let's see, the rule for that is you have, let's see, I guess I should do it up here. So you have f of x, and then you're going to negative f of x. And if you do that, then you reflect it. That's my reflection sign. All right, and then, so now at this point, we've got, let's see, we've got our function is like, let's see, negative 3x minus 4 squared. So that's this one right here. Okay, and now we've got to add 5. So when you add to the function itself, then you will get, you shift it vertically if it's positive, and then if it's negative, you go down. Let's see. Right. So now we have this one, and you can see the black line right here has been shifted up 5. So the rule for that is if you have f of x, and then you go to f of x plus 5, or well, I guess it should be plus a. Then if a is positive, you go up, and if a is negative, you go down. So in our case, it was plus 5, so we're going up. So we shift it up here to that, and then that will give you the function we're looking for, right? Which I guess was g of x equals negative 3 x minus 4 squared plus 5. All right, so now I'm going to try and share my screen, and maybe you can see it on Desmos. Let's see. Okay, so this is the Desmos. So this is what we start with. We start with x squared, and then we're going to shift it to the right. We do x minus 4. So we shift it to the right. And then we're going to stretch it, vertical stretch, by 3. So it goes there. And then we are going to reflect it. It's a negative 3. So it reflects down here. And then we're going to add 5. So you shift it up. And that's the final function that we get. So I hope you can see my screen sharing. But anyway, I think that's enough. And thank you so much.